Similar to the last video that I did, I'm just going to work through some exam questions this time. All of these have been from past actual Edexcel papers. All of the ones I'm going to use today, just so we don't use any materials you may use in exams in the future, are all going to be from the old specification, but they do practice all of the same skills. So the first one is going to be a binomial expansion question. So given that f of x is 2 plus 3x to the minus 3, that is saying that the absolute value, or the modulus of x, so essentially the actual size of x, has to be less than 2/3, which realistically means it has to be greater than minus 2/3 and less than 2/3. So if you try this, pause the video and then come back for the solution. Okay, so first thing you have to do is say that f of x is equal to 2 to the minus 3 lots of 1 plus 3 over 2x to the minus 3. So essentially this is like factorising in the normal way. We're factorising out a factor of 2 from the bracket. But if your bracket has a power, you're also going to have to raise your factor to that power. So when we take the 2 out, it's actually going to be 2 to the power of minus 3. So that is an eighth of 1 plus 3 over 2x to the minus 3. So if we use the binomial expansion formula, specifically this one, because if you use the n choose r formula, it will not work, because that only works when the power is a positive integer. So the formula given is 1 plus nx plus n minus 1 x squared over 2 factorial, and the next term, if you follow the pattern, would be n minus 1, n minus 2. You would have an x cubed, and it would now be over 3 factorial. So if we say, we're forgetting the eighth for now, I'm going to put that out at the front as something we'll multiply by at the end. But we have 1 plus n is our power, and x is actually the entirety of this term here. So we have minus 3 lots of 3 over 2x. Next one is minus 3 for n minus 1 will be minus 4. You need to square all of the 3 over 2x, not just the x. And it's over 2 factorial, factorial meaning 2 times 1, so 2. And then the fourth term, the x cubed term, would be minus 3, minus 4, minus 5, because n, take 1 and take 2. 3 over 2x cubed, all over 3 factorial, which is 3 times 2 times 1, so 6. So I'm going to simplify everything inside of here first, prior to trying to worry about the 1/8. So we still have 1. Minus 3 lots of 3 over 2 is minus 9 over 2x. Minus 3 times minus 4 is positive 12. Divided by 2 is 6. Positive 12. Let's divide by this 2, is 6. We've got 6 lots of 9 over 4. So 6 lots of 9 is 54 over 4, or 27 over 2. All of your exams you have a calculator for, so if you weren't feeling confident, what you could do is type all of this in a calculator except the x, and then just put an x squared next to the term afterwards. So then we have minus 3 times minus 4, which is positive 12, minus 60 divided by 6 is minus 10, lots of 27 over 8, so minus 270 over 8. which would be the same as minus 135 over 4. And then if we want to do an eighth of all of this, we just multiply all of the denominators by 8. So 9 over 16x, 27 over 16x squared, and multiply that by 8, you have 135 over 32x cubed, and that will be your solution. Okay, to that question. So that's from January 2013. The next question, this was done on the week where we were in school, so it's partial fractions. So the first thing you're going to have to do is we're going to have to, because this is equal to a plus b over a factor plus c over a factor, that tells me that it's going to be an improper fraction. Another way of finding out it's an improper fraction is looking at the powers, or the highest power on the denominator and the numerator. So the highest power on the bottom is going to be 4x squared, so x squared. The highest power on the top, 8x squared, so again x squared. So that means that as the powers are equal on the numerator and the denominator, you have an improper fraction. So first thing I'm going to do is I'm going to divide 8x squared plus 2, well, I'll have to put in a 0x since I'm doing algebraic long division, by 4x squared, well, it's minus 2x plus 2x, so no x's, minus 1. So if we see how many times 4x squared goes into 8x squared, you would have 2. Multiply all of this by 2 and you get 8x squared, 0x, minus 2. Subtract them and you're left with 4. So that tells me that our term at the top, 4x squared plus 1 over 2x add 1, 2x minus 1, would be equal to 2 add 4 over 2x add 1, 2x minus 1. Now the bit that comes up next is the partial fraction section of the question, because we need to split 4 over 2x plus 1, 2x minus 1 into the b over 2x plus 1 and c over 2x minus 1. So if we say that 4 over 2x plus 1, 2x minus 1 is equal to b over 2x plus 1, add c over 2x minus 1, then we can multiply through by this denominator, and if we multiply by 2x plus 1, 2x minus 1, this would just become 4. This side, multiplied by 2x plus 1, 2x minus 1, the 2x plus 1 would cancel out, so you'd just be left with b lots of 2x minus 1. And for the same reason, you're left with c lots of 2x plus 1. And this equation has to always be true for any value of x. So what we're trying to do at the moment, like we were before, is find out what b and c are. So we can actually just choose any suitable value of x to try and work this out. For example, if we say let x be a half, that would make this question a lot easier, well, this equation a lot easier, because we'd have b, lots of 2 lots of a half, 1, take 1, so 0. So we actually have no b's at all, so we just have 0. And we would have 2 lots of a half, add 1, so 2c. So that tells me that c is equal to 2. And if we do a very similar thing, but this time use minus a half, this would be eliminated. So we'd be left with 4 equals Minus 1, take 1, so minus 2. So b is minus 2. So that gives our final answer of 2 from back here where we worked out a, minus 2 over 2x add 1, and then plus 2 over 2x minus 1. Now, so far we haven't covered how you would work out the integral of this. I'm skipping that out for now. But if you saw the video I did before on logs and how to differentiate logs, you might possibly be able to work out what these integrate to, as it's just the reverse of that. Right. Next question I'm going to do is, where is it? Next question involves a little bit of radian work and a bit of differentiation. So first thing we need to do is we need to find the differential of this in terms of x and y. Again, take some time to try the question out and pause this, but then come back for the answer. So if we differentiate cos 2x, you would have minus 2 lots of sine 2x, because cos differentiates to minus sine, and if you have more than one x in your cos, then you have to multiply by that number there. Now, for your cos 3y, it will be the exact same thing. Sorry, minus 3 sine 3y. But this is an example of implicit differentiation because we're differentiating y with respect to x. So what we had to do when we do that is multiply anything where we've differentiated y by dy by dx. And that would equal the differential of 1, so 0. So if I rearrange this to get dy by dx, I would probably just move the 3 sine 3y dy by dx to the other side and get minus 2 sine 2x equals 3 sine 3y dy by dx. And then if I divide through by the 3 sine 3y, we get minus 2 sine 2x over 3 sine 3y equals dy by dx. The next part says that a point P lies on C where x is pi over 6. Find the value of y at this point. So if we want to find the value of y, the best thing to do would be to go back to our original equation and say, well, cos of 2 lots of x, so 2 lots of pi over 6 is pi over 3, plus cos of 3y equals 1. Cos of pi over 3, now that is the same as cos 60 if you turned it to degrees, so that would be equal to a half. So a half plus cos 3y equals 1. Cos 3y is a half. 3y. Now, if we have our solutions for y between 0 and pi over 6, I don't have to worry too much about multiple solutions. I can just go back to 3y would be arc cos of a half, or arc cos of a half would be pi over 3. So y is pi over 9. So then, third part, find the equation of the tangent to C at P, given your answer in the form ax plus by plus c pi equals 0. A, b and c are integers. So we've done a lot of the work before. So we have dy by dx. So for our gradient, it would be equal to minus 2 sine 2x over 3 sine 3y, and we have the coordinate pi by 6, pi by 9. So if you put that into here, we have minus 2 sine of 2 lots of pi by 6, which is pi by 3, over 3 sine 3 lots of pi by 9, which is pi by 3. So nicely, they cancel out. So our gradient just becomes minus 2/3. And then if we put that into y minus y1 equals mx minus x1, you can say y minus pi by 9 equals minus 2/3 x minus pi by 6. So y minus pi by 9 equals minus 2/3 of x minus, well, that'd be 2/18 or a 9th. So you actually get quite a nice equation. 2/3 of x plus y, these two have cancelled out, I believe. Yeah? No, it's positive. Sorry, it's positive a 9th. So if I move this to the other side, you get 2/3 of x plus y minus 2 pi by 9 equals 0. And if you multiply through by 9, that would get you 6x plus 9y minus 2 pi equals 0. Right, the last one I wanted to do, video's going on a bit longer than usual, is a question involving e's and logs. So, first part, simplify fully that fraction, and then given this equation, find x in terms of e. So if you want to simplify fully, this goes back to GCSE skills, it will be a case of factorising these two quadratics. So the top, I'm not going to go through how to factorise at this point, but you'll have a 2x and an x, so that's going to be plus 5, that's going to be minus 1. And on the denominator, you will have an x plus 5 and an x minus 3. So that would cancel down to 2x minus 1 over x minus 3. Nice easy few marks, hopefully. So then, given that we have this equation here, log 2x squared plus 9x minus 5 equals 1 plus log x squared plus 2x minus 15, find x in terms of e. So what I would probably do first is use what we had in the first part of the question, so A. It tells me that we're going to, in some way, want to get 2x squared over the x squared. So if you remember your log laws, if we get this log to the left-hand side and it's a minus, you can actually combine the logs in a way that looks like this. I'll show you what I mean. So if we get log 2x squared plus 9x minus 5, take log x squared, add 2x minus 15 equals 1, you could say that log is log of all of 2x squared plus 9x minus 5 over x squared plus 2x minus 15 is equal to 1. Now, they made us do that work in the first part because that simplifies this. I'm not going to go through that again, obviously, because we've just done it. So then, if we want to get rid of a log and get the x's, then the best thing you can do is raise both sides to the power of e. So you would have e to the 1 equals this side. So if we're trying to get x by itself, then multiply through by the x minus 3 and expand it. Then we can try and get all of the x's on the same side. So I'm going to move the ex to the other side to make negative ex, and minus 1 to this side to make positive 1. And if you factorise out the x, you can say that x is equal to 1 minus 3e over 2 minus e. So I'm going to leave it there. I did have a few more questions, but this video is getting quite long as it is. So hopefully you found this useful.